So in this video, we are going to just look over some final further applications of normal distributions. So when we look at the normal distribution, looking at basically the scores and how likely it is to get people in the different ranges, this set of dot points up here just tells us that 68% of scores have a Z-score between 1 and -1. So thinking back to our language of probability, it's mostly in this range. So the data altogether, it's 68%. So it's mostly going to be in this range. So 95% of our scores, we know, are between 2 and -2. So we could say that any random person we select, they will very probably be in this range, right? Like, it's safe to say 95%, that's quite a high percentage. It's very probable that we would find someone in this range. 99.7% of scores, have a Z-score between 3 and -3. So it's almost certainly, we pick a random person, it will be in this range. Now, obviously it's not certain because it's not 100%, but there's 0.3% of our people are on these kind of outskirts, either less than -3 or above +3. Now, going straight into an example, it's saying the heights of children are normally distributed. The mean is 150 centimeters. Let's highlight this. And the standard deviation is 5 centimeters. Now it's saying what percentage of children lie between 145 and 155 centimeters in height. Now what I've got here is I've just got the bell curve, but it's a different type of photo in that it splits up what the percentage is in each of these different sections of the bell curve. So between -3 and then down, between -2 and -3, between 1 and -2. This is taken from our 68, 95, 99.7 rule. This is just going to be here for reference. Now, in this first example, we are trying to find the percentage of children that lie between 145 and 155. So we want to find the Z-score for each. So first, our Z-score for 145, we're going to do our score, 145 minus the mean, 150, over the standard deviation of 5. That gives us -1. And our Z-score for the other, we're doing 155 minus 150 over 5. And that gives us +1. So we are between -1 and +1. So this section in our normal distribution. So 34% plus 34%, that is our 68%. So we know 68% in this range are between 145 centimeters and 155 centimeters in height. So next example. We are given that the mass of 700 jars is normally distributed. Mean is 420 grams and the standard deviation is 3 grams. Now part A is asking us what percentage of the jars are more than 146 grams. So before we can answer this, we want to find the Z-score of this 146 grams. So for part A, we want to find our Z-score. So that's going to be 426 minus the mean, 420, over 3. So that gives us a Z-score of 2. So that means, thinking back to our normal distribution, this score is right here. Now, we know in between -2 and +2 is 95%. So this whole bit is 95%. Now, outside of this range, so above two standard deviations and below -2 is going to make up 5%. So we can say the scores outside the range is 100 minus 95, which gives us 5%. So that means that 5% of our data is on this bit and on this bit as well. But we are just looking for the ones that are more than 426. So that's half of that. So more than 426 equals 5% divided by 2. which gives you 2.5%. Okay, next one. It's saying less than 423 grams. So part II. Before we do anything, we want to find the Z-score. Then we can apply our percentage. So for part II, we're going to do Z equals to 423. Minus 420 over 3, which gives us 1. So we're trying to find the ones less than 423 grams. So looking back at our normal distribution, we have basically everything up to about here. That's what I've done this the other way around, haven't I? We're trying to find less than 423, so these ones here, as well as this one. So it's everything less than 1 standard deviation. So we have, remember, on the left-hand side of the mean, this part makes up 50% plus another 34%. So our percentage is going to be 34% plus 50%. That equals 84%. So that means to have a score less than 423 grams, there is an 84% chance. So 84% of our scores are less than 423. We are just using our normal distribution, and I've broken it up into parts here to make it easier for you to work with. Now in part B, it's saying what percentage of jars are predicted to have a weight between 414 and 429. So let's just calculate the Z-score for each of these first. So the Z-score of 414 is going to be 414 minus 429 over the standard deviation was 3. So that gives us, 420. Why did I do 429? We are subtracting the mean from this, okay? So we have to always minus the mean. And that gives us -2. And then let's find the next one as well. So the Z-score for 429, we have 429 minus 420 over 3, which gives us a Z-score of 3. So we are looking in between -2 and +3. In between -2 and +3. This entire section here. So let me actually just highlight it. We're looking for this part here. So since we have all of these percentages, we can just add them all together. So we have 13.5 plus 34 plus 34 plus 13.5 plus 2.35. You can also use the 68, 95, 99.7 rule in that in between -2 and +2, we have 95% in there, plus our 2.35 gives us 97.35. So a couple of ways we can do this, but I'll just go between -2 and +2 equals 95%. And then between +2 and +3, and 3 equals 2.35%. So therefore, between -2 and +3, or between 414 grams and 429 grams, is 97.35%. So that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.